Okay, now we move towards another term, that is packing fraction or efficiency. Packing fraction and efficiency. What is packing fraction? The space occupied by an atom in the unit cell is called the packing fraction. What is the percentage of packing fraction? That is Z effective of it into volume of an atom by volume of shell into 100. Okay, now we will going to discuss for the cube whose length whose edge are 8a length, and the atoms of having radius, having packing fraction Z into 4 by 3 pi r cube by a cube, that into 100. This is the packing fraction for those cube whose edge length is a, okay, and whose volume we know. Okay, some of the cases that we can learn from the packing fraction. First case is for the cubic cell, for the simple cubic, the packing fraction, the percentage of packing fraction, that is Z into 4 by 3 pi r cube upon a cube into 100. Here Z effective, that is equals to 1. Here r equals to 2a, 2r equals to a. By putting it, we come to know about the packing fraction of it, that is 52.4, that we have to remember. Now we move towards the another packing fraction, that is in BCC, body center packing fraction. Percentage of it, that is equals to packing fraction, that is equals to again the same formula. Here Z into 4 by 3 a pi r cube upon a cube into 100. Here Z effective is nothing but 2, and here the relation between 2 are, that is equals to root 3 by 2a, that is the relation. By putting it, we come to know about its packing fraction, percentage of packing fraction, that is nothing but 68%, that we have to remember. Okay, again last in FCC a packing fraction, that is percentage of packing fraction, and here we know Z effective is 4, and the relation between the edge length of the cubic cell and the radius of an atom is root 2 by 2a. Okay, and here percentage of packing fraction finally come out, that is 74%. All three of them, that is important, and we have to remember it carefully. Okay, now move towards the another topic, that is and before moving towards another topic, I wanted to introduce one more terms, that is edge center. Edge center that contribute to the unit cell. It's only 1/4 part. Similarly, I also wanted to tell you one more terms, that is what is the meaning of alternate. What is the meaning of alternate? If given there was an alternate body center, alternate face center, alternate edge center. So remember, in the cube there was an alternate body center was 4, alternate edge center is 4. Everything in the cube having alternate is 4 except the face center, that is face center, alternate face center in the cube is only 2, and according to which we can proceed. According to the question, there was a question which comes related to it, that is alternate body center was given, and we have to find it. It was not equal to the body center of the normal. Okay, now we move towards the another topic, that is the element of symmetry. The element of symmetry. Here the element of symmetry first is COS, that is center of symmetry. There was different is POS. POS is different. There was two types, that is RPOS, and there was another DPOS, that is rectangular plane of symmetry, and DPOS, that is the diagonal plane of symmetry. There was third is asymmetrical AOS, that is asymmetrical symmetry. Okay, now we one by one we come to learn about all of them. In a cube there is a one CUS that is at body center. In cube there was only one CUS at body center. Okay, in RPOS there was a 3 RPOS in a cube, and there was only of 9, there was only one DPOS in the cube. What is RPOS? RPOS in a cube what is RPOS? RPOS, if you consider, if we able to know you by another pen, there was this kind of thing will happen, and like this the atoms involved in it is the edge center atoms, that is the edge center atoms, that is the face center atoms. The means the atoms which is involved in it is, that is the edge centers, that is edge center atoms, edge center atom, that is face center atoms, and we miss one more, that is the body diagonal atoms, that is the body diagonal. That all comes in the RPOS. So total number of atoms involved in RPOS is number of atom involved is 9. Okay, now we come to the another one, that is DPOS. In DPOS there was a cube. Here the atoms of a diagonal will be involved, means these are the atoms which involve that is taken. That here the atoms involved is not only the atoms of corner, and not only the face diagonal atoms, but also the body center of it, and also the edge center. Here the 4 type of atoms is present, that is firstly, that is the corner atoms, that is the face center, that is the edge centers, and also the body centered. Okay, the total number of atom involved here is also 9. Total number of atom involved here is also 9, similar to that of the RPOS. Let's move ahead to the another term, that is AOS, that is axis of symmetry. Axis of symmetry, that is axis of symmetry, that is AOS. Axis of symmetry are of 3 types, that is C2 AOS, that is C3 AOS, and that is C4 AOS. That is in C2 AOS, I will explain all of this by making a cube, so that you will able to understand it very well. Okay, The cubes are not good, but okay, you will understand by it. Okay, we can use a different color pen so that you will able to understand and it very easily. Okay, so come to the first C2AOS. That in C2AOS, the atoms of the S in H centers will be included. The atoms of the diagonal opposite S centers will be involved, like this and this atoms, and also the body diagonals will be involved. That is C2AOS. There's how many edges are present in the cube. Of course everyone knows there was a 12 edges are present, and if the opposite of the symmetry, if opposite S centers are considered, so there is total number of 8 C2AOS is 6. There was 6 C2AOS axis of symmetry in cube. There was a total 6 C2AOS in cube. Then we move towards the A3COS. A3COS, there was a diagonal opposite corners. There was a diagonal opposite corners. There was a diagonal opposite corners, and there was a body center here. So there's how many corners? There was a 12 corners, and if we consider the opposite corners as the symmetry, so there was how many C3AOSs exist in it, a cubic cell? There was 6 C3AOS present in a cube. Similarly, if we move towards the C4AOS, there was a edge, not edge, it was a face center. They are face centered atoms. That is face center atoms, and body center will also involve. There was the face center atoms. So as how many faces are there in the cube? There was a 6 faces in the cube, and if we take the pair and making at a symmetry, so number of C4AOS will exist in the cube, that is 3. There was 3 C4AOS will exist. So this is the way through you can imagine and able to learn the concepts very easily. Okay, so now we can conclude the thing, that is the element of symmetry here. Element of symmetry, that is, it is COS, it is POS, it is AOS. COS, there was a one COS which exists in a cube. There was RPOS, and there was a TPOS. In RPOS, there was a 3 RPOS. There was 3 RPOS which exist. In DPOS, there was on 6 DPOS will exist in cube. And in AOS, there was C2AOS, C3AOS, and C4AOS. C2, there was 6 C2AOS exist, there was 6 C3AOS exist, and there was 3 C4AOS exist. So number of element of symmetry will exist in a cube. Number of element of symmetry, element of symmetry in cube is nothing but 23. Okay, let's move ahead to the another topic. Okay.